Hello dear students, today we'll talk about the difference between base and a nucleophile. So our learning objectives will be to understand the definition of a base and nucleophile, compare their roles in chemical reactions, identify key differences along with example that will learn us to know how to distinguish them in a chemical mechanism. So what's the base? So according to Lowry theory, base is any species that accepts a proton, right? And what's special about if you have to identify a base, it's simple that any species that has a lone pair of electrons or it has a negative charge will always act as a base. And whatever the base is, its unique function is that it will always pick up a proton. And acid base reactions involve bases, right? For example, if we have reaction of HCl with base like sodium hydroxide here, so this reaction will result in the hydroxide taking up the proton, right? Since hydroxide is taking up the proton, it's picking up the proton, therefore this hydroxide will act as a base in this reaction. So what about a nucleophile? Right? Nucleophile is any species that can donate an electron pair, right? And it will always result in formation of a new covalent bond. So previously we saw that base was a species that picks up a proton, whereas nucleophile has nothing to do with a proton. So if any species does not pick up a proton but donates an electron pair, and form the new covalent bond, then that species will be considered as a nucleophile. So what are the key features or characteristics of the nucleophile? It will always be electronically rich, right? It can have lone pair, it can have a negative charge, and it always attacks electron deficient center or the electrophilic centers. And nucleophile are always involved in reactions that are either substitution or addition reactions. Right? This is key characteristic, whereas the base was involved in acid-base reactions. It was also electronically rich. Nucleophile is also electronically rich. Base was always picking up a proton, whereas a nucleophile does not pick up a proton. It just donates electron pair to form a new covalent bond. For example, we have a hydroxide ion here, and this hydroxide is doing what? It's attacking this methyl group. Why methyl? Because this carbon of the methyl group is partially positive because it's deficient. Why it's deficient? Because it has a chlorine atom in the proximity which is electronegative, and this chlorine atom is make the methyl carbon electron deficient or electrophilic. So since this carbon is electrophilic, the hydroxide being electronically rich will attack on this carbon, resulting in displacement of chlorine. So here you can see the chlorine has been displaced and hydroxide ion has attached itself in place of the chlorine. So this is basically a substitution reaction. So here you can see that in previous example we had also hydroxide ion, and in this example we have also hydroxide ion, but here it's acting as a nucleophile, and in the previous example it was acting as a base. So it's an important concept that if you have a base, it can act as a nucleophile, and if you have a nucleophile, it can also act as a base. It depends on the conditions. So here we have some common examples of species, such as hydroxide ion. We have just saw that hydroxide can act as a base, it can act as a nucleophile. Ammonia, it has also lone pair of electrons. You can see it does not have a negative charge, but it has lone pair of electrons on nitrogen. So it can act as a base, it can also act as a nucleophile. Chloride ion is highly electronegative. So it will act as a nucleophile, but normally it does not act as a base. Hydride ion can act as a base as well as a nucleophile. Tertiary butoxide ion can act as a base, right? Because tertiary butoxide ion is a very bulky group. So it's easier for the tertiary butoxide ion to pick up a hydrogen, which is very teeny species, but it's not possible for the tertiary butoxide ion to attack an electrophilic center, which will definitely be much bulkier than a proton. So I hope that these concepts of base and nucleophile are clear to you. Thank you.